Okay. So here a low-rise building with a plan dimension is given. Where it is located, it is near east coast, and it is given it is under terrain category 3. And next one it is given it is on a leveled ground. Design life is given as 25 years. Compute the design wind pressure. Okay. So what is that information is given there? What you have to calculate it. Where the building is located, where it is located,
Terrain.
uh, uh, no, where exactly the building is located?
Near sea.
Near the seashore, east coast. So you have to take a city where it is in the east coast. Okay, because you need to find out what is the design basic wind speed. So which one will you take? Will you take Chennai?
Yes, ma'am.
Okay, so it is we can assume because Chennai is also near the east coast. Okay, it is near the east coast. So we will select the city as or the region where the building is located as Chennai. Okay. So once we select Chennai, what is the basic wind speed VB? What is the basic wind speed of Chennai?
44 to
50, 50. Chennai is 50. Okay. Chennai is 50 meters per second. Okay. If we can see here, I think your code at the end there is an annexure given. Let us check once again whether it is any. There is an annexure.
Page 8, ma'am.
Page 8, city town is also given there. Okay. Page 8, can you see that in the figure? Chennai is 50, no? No, Chennai, page 8, you can, there is some, I think at the end there must have given a city like that, isn't it? It is not there now. See the end, last pages. See here, page number, annex A, page number 53. Because from the map it is difficult, like exact town you may not be able to, otherwise you should have a color map. Where is Chennai? You can see Chennai is at 50. Isn't it?
Yes, ma'am.
So Chennai, focus here, the annexure A, basic wind speed at 10 meter height for some important cities and towns it is given here. So you have to select if it is not specifically if it is not mentioned which is a city, if it is telling that is the east coast, you can select any city near the east coast, okay, or any town. So our Chennai is in east coast, so we can take Chennai and the basic wind speed is 50 meters per second. Okay. So basic wind speed is taken as 50 meters per second. Next, what is the, to calculate the design wind pressure, that is your first PZ, design wind pressure is nothing but 0.6. This is not design wind pressure now, this is the wind pressure. First let us calculate this, 0.6 Vz square, where Vz is the design wind speed. This is the basic wind speed, this is the design wind speed. So how to calculate the design wind speed? Vz is equal to Vb into K1, K2, K3, K4. Okay, this is the equation for the design wind speed Vz, Vb, K1, K2, K3, K4. Now Vb you know 50 meters per second. Now each parameter you have to find out what is K1. K1 is nothing but the, what is K1 is called, it is the risk coefficient. K1 is known as the risk coefficient. So which table you have to refer that? Table 1 I think. Okay. Table 1 of the IS 875 part 3 will give you which page it is? It is page number 9. You can note down it's a page number 9, table 1. Can you tell me from this, refer this table 1 and tell me what will be the value of K1? What is it? Did you see the question? What is the question? A low-rise building having a plan dimension, all these things. The design life of the structure is 25 years. Okay. So you have to refer the table number, in the table.
90.
So with the design life 25 years, a low-rise building, with the 50 meters per second wind speed, the value of K1 is how much now here? 0.9. Isn't it? So your K1 value is 0.9. Now what about K2? You have to find out K2. So for K2, which table you have to refer? I think it may be table 2. It is table 2. See? Table 2. What is the height of the building? Is it mentioned there in the problem? Height of the building is not mentioned. Okay, so you have to assume.
No, ma'am.
It is not mentioned. So you have to assume it because it's a low-rise building. Okay, low-rise building, maximum how much you can have the height?
Below 20 meters.
Below 20 meters. So you can take, because the life of the structure is only 25 years. So it may not be a multi-storied building. Maybe maximum of a 2-story building. Okay, so you can take up to 10 meter or 15 meter maximum. Okay. So you can write down, assume the height of the building as, assume the height of the building is how much you will take? 15 meter?
10 meter.
10 meter. Okay. So assume the height of the building as 10 meter. So take it as 10 meter. Now refer this table and tell me. And then this is in which category it is given? Terrain category is which category it is given in the question?
3.
Terrain category 3. So in terrain category 3, height 10 meter. What is the value of K2?
0.91.
0.91. 0.91. Very good. So your K2 factor is 0.91. Okay, this is from table 2. Okay, table 2. Now what is next factor? Is K3. K3 is what? What is known as K3? Known as K3 is known as the topography factor. Okay, so topography factor. So what is the topography? What is it mentioned here? It is on a leveled ground. It is on a level ground. So for a level ground, what is the topography factor? You see here 6.3.3.1. Okay. The value of K3 may be taken to be equal to 1 if the slope is less than 3 degree. Okay, less than 3 degree. So what is the value of K3? Less than 3 degree is nothing but almost it's a leveled ground. Okay, it's a leveled ground. Your value of K3 is how much?
1.
1. Okay. So K3 is taken as 1. Otherwise, you have to calculate the value of K3. Okay, I'll tell you just 1 minute. I'll explain you. You come to the last annexure. Say annexure B. Annexure B, changes in terrain. Annexure B or C, maybe C. Annexure C. See, Annex C, you can see effect of a cliff or escarpment or on equivalent height above ground, K3 factor. Okay. So K3 factor, it is given here. How to calculate the K3 factor if the slope is greater than 3 degree. Between 3 degree and 17 degree, how to calculate the K3 factor? You can see an equation here. K3 is equal to 1 plus C into S naught, where C has the following values. if the theta is between 3 and 17 degrees, C is equal to 1.2 Z by L. If theta is greater than 17 degree, your C value is 0.36. What is Z and L? All this, how to calculate L? How to calculate Z? What is Z? All these are explained here. You can see it is from this diagram, it is mentioned here. Okay. This is a leveled ground. This is the upwind slope. This is the crest. This is the down slope. Okay. So the building where it is exactly located, this is from the starting of the upwind slope to the crest. This is the length L. This is L. And from here to the crest, this is Z. Okay. So accordingly, using this equation, you can find out the value of K3 if the theta is greater than 3 degree. Correct? Understood? Okay. So now in our problem, the value of K3 is 1 because it is in a leveled ground. Next one is K4. How many of you have studied wind engineering subject in your BTech program? Anybody has learned wind engineering?
No, ma'am.
Anybody?
No, ma'am.
No one.
No,
So
ma'am.
now it is new to you, isn't it?
Yes, ma'am.
You are learning for the first time, isn't
Yes,
it?
ma'am.
Okay.
Yes, ma'am.
Okay. Because I'm going little fast because this is a big subject actually. It's a vast course. Wind engineering is a course actually. So you need to know a lot about wind engineering. There are so much of concept and theory behind it. So, but your design of tower structures, it's a small portion is given as wind loading. So I'm just concentrating only how to calculate the wind load. Okay. So don't feel anything that you are not able to understand the concept and that is different subject. Okay, if time permits, we can discuss it elaborately. Now we concentrate only how to calculate the wind load. Okay.
Okay.
Now what is the next one? K4. K4 is what? K4 is nothing but the cyclone, importance factor for the cyclone region. Okay, now let us go back. How much is K4 given there? K4. K4, the value of K4 is given as very important structures, it is 1.3. For industrial structures, it is 1.15. For all other structures, it is 1. Okay. So now your K4 value is also in this problem, it is 1. Okay. So now tell me what is the value of Vz. Calculate and tell me what is the value of Vz.
$40.95.
40 point, because your basic wind speed was 50. Now with all the parameters including, now it is coming as 40.9. Is it correct?
40.95.
Okay, 40.95 meters per second. So this is the design wind speed. So you need not design your building for the basic wind speed. Okay, so it is reducing now. Okay, design wind speed, when you take from the basic wind speed, it is reducing to 40.95 meters per second. So once you know so this is called the design wind speed. So once you know the design wind speed, you can calculate the design wind pressure, Pz. Calculate and tell me. Pz is equal to 0.6 Vz square. How much? How much? Pz.
1006.14.
Tell me once again.
1006.14.
1067.
06.
1006. 1006.
0.14.
0.14 unit. What is the unit for PZ? It is, I'll show you here. PZ is, say, design wind pressure at height Z in Newton per meter square. Okay, so this 0.6 actually, it is actually by, it is density of air, that is P by 2 actually, the rho by 2. Actually this equation 0.6 has come. Density of air is 1.2 Newton per meter cube, that divided by 2. That is how this 0.6 has come. So finally the PZ unit is in Newton per meter square. Okay, Newton per meter square. So this is 1006.14 Newton per meter square. Okay, so the wind pressure is 1006.14 Newton per meter square. Okay, is this much clear to you? This is the basic calculations. This is for any wind load calculation. This is the, I don't know whether you must have studied your steel structures too during your BTech program. You must have calculated wind load, trusses, roof structures and all. When you learned, you must have calculated the wind load. In steel structures you must have learned, I don't know, or you must have forgotten. So this is the basic calculations for any wind load calculations. You have to do it initially. Okay. Now the design wind pressure PD is KD into KA into KC into PZ. Okay. So all these values, I think I will not much. Your KD is taken as 1. Okay, KD is 1. What about KA? KA depends upon the tributary area averaging factor KA. If it is less than or equal to 10, it is 1. So depending upon the area. What about KC? What about KC? Okay, you can go through that. Okay. For a plate type element, the area of integer plate is taken as tributary area. Okay. Okay, so this almost these values, it is not much important, or you can take PD is equal to 0.7 PZ also, you can calculate it. Okay, in a simple way you can calculate it as the design wind pressure is equal to 0.7. This is the maximum value, 0.7 PZ. That way you can take, you can just write down the design wind pressure PD is equal to 0.7 PZ. Tell me how much it is. That means 70% of the wind pressure is sufficient as design wind pressure.
704.29.
704.29 Newton per meter square. Okay, so this is how finally the design wind pressure you are going to calculate. Okay, so from the design wind pressure you can calculate the wind load also. Okay, so wind load, 1 minute. So once you know the design wind pressure, the F is equal to, okay, one equation you have, if it is for an individual element, you know, I have told you CPE minus CPI into area into the design wind pressure. Okay, so this design wind pressure you have calculated, you know the area, tributary area on the surface area on which the wind is going to be affected. CPE and CPI can be calculated based on the number of openings in the building and the type of the roof and the geometry of the structure. Okay, so once you know all these things, your F load, the wind load on individual members can be calculated based on this equation. Okay, or if it is a dynamic analysis, you have another thing, F is equal to a force coefficient CF into area into the design wind pressure. Okay, so this force coefficient I've showed you, I scrolled down a lot of information to you how to calculate the CF values. Okay, in the code it is given how to calculate the force coefficient based upon number of parameters. There are so many variable parameters available. So based on that you can calculate the force coefficient. So once you know the force coefficient, once you know the design wind pressure, once you know the area, you can calculate the wind load on the structure. Okay, is it clear? Now these are all the static type of analysis. Now for dynamic analysis, what we can do, there is another important addition that you have to add. It is in dynamic analysis. Okay, if it is for a dynamic analysis, I'll just show you how to calculate it. Please come back to page number 47. Okay, please note down, it is page number 47. Page number 47 of your code book. A dynamic effect is given. Okay, so the dynamic effect, when you have to consider, there are two parameters given here. Buildings and closed structures with a height to minimum lateral dimension ratio more than about 5. That means the height to width ratio of the building is more than 5. Then you have to go for a dynamic analysis. That is one criteria. Next criteria is when the building and structures whose natural frequency in the first mode is less than 1 Hertz. Last class I was telling, when you learn structural dynamics, you must be learning about the natural frequency and the mode shapes, how the building is going to vibrate for lateral loads or for external load. So in the first mode of the vibration, if the natural frequency of the building again depends upon the stiffness and mass of the building. Okay, so if the natural frequency in the first mode, if it is less than 1 Hertz, then you have to again do for a dynamic analysis. Any building or structure which satisfies either of the above two criteria shall be examined for dynamic effects of wind. Okay, is it clear? So this is how you have to go for a, in general, the following guidelines may be used for examining the problems of wind-induced oscillations. Okay, so dynamic analysis, you please go through, please read all these informations. See how to calculate the time period, how to calculate the etc. etc. So these are all the dynamic effects. After this, whatever it is mentioned, 9.2, 0.1, etc. everything is the dynamic effect on the structures. I'm not going to explain all these things into you. Okay. So how to calculate the dynamic wind response? When you do a dynamic analysis, okay, your wind load calculation, you can see an equation here. You can see, can you see this equation? Fz is equal to Cf into A into PD into G. That means I'll explain it. I'll write it here. If it is a dynamic analysis, your F equation is Cf into A into the design wind pressure into one more parameter that is called G, and this G is known as gust factor. Okay, gust factor. Okay, you know these three terms are same, isn't it? Similar to this, isn't it? If it is a static analysis, it is Cf into A into PD. But when it comes to a dynamic analysis, same Cf into A into PD multiplied with another factor known as gust factor. That gust factor includes all the dynamic effects. Taking into account of all the dynamic effects on the building will be taken into consideration. So that factor also have to be multiplied with the static analysis coefficient. Then you will get a dynamic analysis. Okay. So this calculation of G is another important calculation. If time permits, we will discuss all these things. You can go through this. It is self-explanatory because this G all these things, Fx, As and PD, you know. When we talk about G, see, G is known as the gust factor, and it is given by a big expression. It is given here. Okay, a big expression is given here. You can use the Codal provision and you can calculate the value of G. See, I'll explain just a simple explanation. I'll give 1 plus R. R represents the roughness factor. So that means we are including the roughness of the terrain. How rough, even the terrain is a category 1, 2, 3 or 4. Again, the roughness, the turbulence intensity, everything has to be taken into consideration. Okay, G is the peak factor. Fluctuation, velocity fluctuation has to be taken into consideration. There is another term called B. B is called the background factor, indicating the measure of the varying component of the fluctuating wind load. You know that when a wind load is, when you using an anemometer, when you measure, you can see this is how your wind load graph will come. Okay, which is the instrument which uses the wind velocity? You know the name of the instrument which measures the wind velocity? It is called anemometer. Okay, please note down. It is known as the anemometer. Anemometer is an instrument which measures the wind velocity. Okay, what is the instrument which measures the seismic waves or the seismic waves? Which is the instrument? Earthquake, how do we measure? It is measured using an instrument called seismometer. Okay. Okay. Seismometer measures the earthquake waves. Anemometer measures the wind velocity. Okay. So using an anemometer, if you measure the velocity, the velocity is it's just fluctuating. It is not constant. For every second, the velocity is fluctuating. Okay. The velocity variation, sometimes it goes up and down, and there will be peak velocity. Okay, so it is actually fluctuating. So you have to average all the velocities and find out. Okay. So it's a very complicated nature of the wind velocity. So you have to take out a particular factor, the fluctuating wind load, the background factor. Again, for there is a big expression is given there. Then you have this phi. It's a factor to account for the second order turbulent intensity. It's a turbulence. It's a big, you know what is turbulence? In fluid mechanics, you must have learned laminar flow and turbulent flow, isn't it? You have heard of turbulent flow and laminar flow?
Yes, ma'am.
So similarly, because like a fluid, air is also a fluid. Air is also considered as a fluid. So when the fluid moves, there will be turbulence. Those who have traveled in flight must be knowing, because when the flight goes into a cloud, you can see a turbulent effect, isn't it? A turbulent effect will be there. You can feel that, the turbulence. So similarly, the turbulent factor also has to be, when the wind is blowing, even for the building, there will be a turbulent effect of the wind. So that factor is phi. So all these are all some of the size reduction factor, height factor, turbulence intensity factor. There are so many other factors, that is E, turbulence, winds, the average breadth, etc., etc. You can see a number of parameters that is included. So a combination of all these parameters taken into consideration, we have a gust factor. Okay, so that gust factor, when we multiply it with the other coefficients, you will be getting the wind load in dynamic analysis. At least, did you get an idea what is the static analysis and dynamic analysis? Did you get some idea? Okay. So this is how we calculate the wind load on a structure. This is what at this point you understand this much. Okay, and when you go through the code book, you can understand much more. Again, along wind response, across wind response. There are so many other things. There is a damping coefficient. If it is a building, that also has to be considered. So considering all these parameters into consideration, so a combination of along wind, across wind, so many other things are there. So I told you, it's a very vast course. We cannot discuss everything in a single class. So with this, I will complete the second unit. I'll just show you the syllabus. Okay, I'll just take the syllabus and I'll show you. BTS, where is the syllabus for you? Okay, can you see the syllabus?
Yes, ma'am.
So the first module, the design criteria, we have completed the design philosophy, the materials, modern concepts, and you people started taking the seminar, high performance concrete, fiber reinforced concrete, lightweight concrete, self-compacting concrete. Those are not completed, please prepare the PPT and share it in the team. Okay. So accordingly, you can upload it in the MS team. My PPT also, I will be uploading it today. Whatever units I have completed. So this first unit we have completed. Isn't it okay? And second unit, loading, gravity loading, dead load, live load, impact load, construction load, sequential loading, wind loading, static and dynamic approach. That is what I have taken now. The analytical method, wind tunnel experimental methods, earthquake loading, equivalent load, response spectrum method, combination of loads. Are you okay with this? These 2 units now? Did you get an idea? I will upload my PPT today. You can go through the PPT, refer because second unit almost the major part is from the codal provision. Okay, ISA 1893 and IS 875. Is there any clarification?
How many marks for test, ma'am?
How many marks? It will be a very small test covering the first unit and second unit. Maybe for 30 marks. Okay. You may have some MCQs and something you have to write. Some 1 or 2 problems will come from earthquake loading and wind loading. So before that, you have to keep your IS code books ready with you. Now, are you happy with that progress of the subject? Or is there any difficulty? This.
No,
Any feedback? Anything to be improved? What about the other subjects? How many units completed? Because you have to go a little fast because you have started very late. We have to complete it. What about other subjects?
They also completed almost 2 units, ma'am.
Almost 2 units. So we are all in the same pace only. So before going to the third unit, we will have a small test Monday. Please prepare it. And what about the Ethiopian students? Are they not attending the classes?
Ma'am, they have Christmas now, so.
Oh, they have Christmas now.
Yes, ma'am.
Okay. So Sharath is completely out of touch. He's not attending. He's not responding.
Yes, ma'am.
Okay, then we will close this today's class. You please download the videos and keep it ready with you. I don't know. It will be there in your MS Team, isn't it? Videos.
Yes, ma'am.
Oh.